so as I said, we are going to start chapter 4 of the lab section of the book. This is the first model that we are going to work on. And in this model, we are going to learn how to take care of multiple arrivals and some various features of ProModel. What I want you guys to do is to, still we are working on the folder for week 3. So in that folder, please create a new model. We are going to call that model or name that model as PCB store dash multiple arrivals, okay? PCB store dash multiple arrivals. So please create a new model in the folder for week 3 and name your model as PCB store dash multiple arrivals, okay? So this is the structure of the model. We have a PCB store and 2 types of PCBs, PCB1 and PCB2 arrive to the PCB store. After they come to the PCB store, they go through area 1, area 2, area 3 for process. However, the order by which they go through these areas to get processed are different from each other. For PCB1, the PCB1s, after going to PCB store, then they go to area 1 and then area 2 and then area 3. However, PCB2s, after going to PCB store, they go to area 2 and then area 1 and then area 3. And here also I have specified the processing time on each one of these areas, 12 minutes, 15 minutes, 20 minutes, and for PCB2, 7 minutes, 5 minutes, and 10 minutes. And all of them are exponentially distributed. So the processing time of PCB1 and PCB2 on each one of these areas have been identified as well. And as you can see, they may have different processing time on the same area. For example, PCB1 on area 1 has 12 minutes processing time exponentially distributed, but PCB2 on area 1 has 5 minutes processing time exponentially distributed. And after they are done processing on these areas, then they exit the system. So there are 2 entities, and I know the process that they go through in these locations. One more piece of information that I have is that we get 1 batch of 500 PCBs of each type. So I get one batch of 500 PCB1, and I get 1 batch of 500 PCB2 at the start of the simulation, and then that's it. So that's all I know about the arrival process. We get 1 batch of PCB1, 1 batch of 500 PCB1, and 1 batch of 500 PCB2. So now we want to develop a model to capture this system. Tell me how many locations I have here.
Is it 4?
4, PCB store, area 1, area 2, area 3, and just pay attention that all of them have capacity of infinity. They can just process as many entities at the same time as possible. How many entities I have?
2 entities.
2 entities, PCB1 and PCB2. How many arrivals I have?
2.
Because?
2.
PCB1 and PCB2 come in separately?
They come separately, and also pay attention that if you remember in previous model that we did in previous week, we had multiple entities we had 4 entities actually in our simulation model. However, only one of them came from outside. And because of that, we had 1 arrival. The rest of the entities were created inside the system. So we took care of that in the processing. However, here I have 2 entities, but both of them are coming from outside the system. It's not that inside the system, PCB1 is going to be transformed into PCB2. No, PCB1 and PCB2, both entities are coming from outside to the system. And when we have entities that are coming from outside, we always specify 1 arrival for each of them. Okay, so here I have 2 entities, and I'm going to have 2 arrivals just because both of them come from outside the system to the system. So I need to capture their arrivals. And this sentence, as I said, is the only thing we know about the arrival. We get 1 batch of 500 from each one of these PCB types, PCB1 and PCB2. I want you guys to please create a model, PCB store dash multiple arrivals in the folder for week 3, create the locations, create the entities, create the arrivals, and you can also do the processes. do the processes, and I will call your names and I'll check your progress as you go forward. Okay. So I have 4 locations: PCB store, area 1, area 2, area 3. And as I said, all of them have capacity of infinity. And I have only one of each. So the unit is 1 for all of them. And for the queuing rule, I leave the queuing rule for all of them as no queuing rule. So can you tell me where should I go to change the queuing rule for these locations if I need to?
Under rules,
In the rule. This is a place where we can change the queuing rules, because these locations have capacity of infinity. So we have to tell the simulation how they are processing here, being processed, and how they go to the other locations. So I want no queuing rule in all of these locations. Okay. Then in terms of the entities, we have 2 entities, PCB1 and PCB2. And then for the arrivals, this is all I know. We get 1 batch of 500 PCB1 and 1 batch of 500 PCB2. And we said we have 2 arrivals, 1 for PCB1 and 1 for PCB2, just because both of them are coming from outside to the system. Now, let's think about the arrival of PCB1. We get 1 batch of 500 PCB1. Can you tell me what is the quantity each for PCB1?
500.
500. Can you tell me what does quantity each represents first? One more time, and then we talk about the value. Number of entities that come to the system in each arrival. Okay, that's quantity each. When one arrival happens to the system, an entity comes to the system, how many entities arrive at the same time? That's what we put in quantity each. And you said you put 500. What's the reason you put 500?
It says a batch of 500 of each type.
We get a batch of 500. So when one arrival happens to the system, when entities come to the system, we get 1 batch of 500 entities all together. They come to the system together in 1 arrival. So quantity each for PCB1 is 500. They all come together at the same time, and they go to PCB store. They go through the rest of the process one by one. It's not that they come in a batch of 500 and they go through the rest of the process in a batch of 500. No, that's not the case. They arrive to the system in a batch of 500. All of them go to the PCB store, but then they go through the rest of the process one by one. Okay, so make sure you understand that part clearly. They arrive in a batch, but they go through the rest of the process one by one. They arrive in a batch of 500, so the quantity each, which shows number of arrivals that happen at the same time, is 500. What is first time? The time that they can come to the system?
Would it just be 0?
It's just 0. They can come to the system from the start of the simulation. What is occurrence?
1.
Can you tell me what occurrence shows first, and then we talk about the value?
Occurrences are how many times the arrivals come.
Exactly. How many times arrivals happen in your system? Is it just 1 arrival of 1 or a group of entities, or no, it just happens over time? When we put infinity for the occurrence, that means arrivals can happen to your system for as long as you run the simulation. But if that's not the case, I want only 3 entities come to the system, I want only 1,000 entities come to the system, and if each arrival brings only 1 entity, then for the occurrence, I put 1,000, for example, to say, okay, only 1,000 entities will come to the system, assuming that each occurrence brings only 1 entity. So for occurrence, here, all I know is that we get 1 batch of 500 PCBs. 1 batch of 500 PCBs. So how many arrivals happens? How many times arrivals happens in this system? 1 batch of 500 arrive to the system, and that's it.
Is it only once?
It happens only once. 1 arrival happens, but in that arrival, 500 entities come together. Okay, perfect. Take care of that in quantity each. 500 entities come together in one arrival, but only one arrival happens. So occurrence, which shows how many times the arrivals happen, is 1, only 1. If you put infinity, that means for as long as you run the simulation, batches of 500 will come to the system. But that's not the case here. We get only one batch of 500 entities, and that's it. So arrival happens to the system only once. So your occurrence should be 1. So, so here we get only one batch of 500. So the occurrence is 1 and only 1. If you put infinity for the occurrence, that means for as long as you run the simulation, these batches of 500 will come to the system. But that's not the case here. We get only one batch of 500 and that's it. So occurrence is 1. Now, tell me what is frequency then. Tell me what we put in frequency and then what is the value here. Frequency is inter-arrival times. Time between consecutive arrivals. Okay? Frequency is time between consecutive arrivals or inter-arrival time. And tell me what is the value here.
Would it just be 0?
It's 0, or basically we don't need that information at all. Because here I only have one occurrence. There is no second occurrence, so I worry about the time between arrivals. There's no second arrival. There is no third arrival. I don't need to worry about the time between arrivals. There is only one arrival in this system, and that's it. So I don't need to worry about frequency. You can leave frequency at 0 or empty. Both of them are fine. I don't need to worry about frequency. That information will not be used in the simulation because only one occurrence, one arrival happens in this system, only one arrival. So I don't need to worry about the time between arrivals. There is no second arrival or third arrival or anything like that. Okay. Is everyone okay so far? So let's go to arrival for PCB1, which arrives and goes to PCB store. I get 500 for quantity each. All 500 arrive at the same time in a batch from the start of the simulation. Occurrence happens only once, only one arrival happens, and frequency is 0. I don't need to worry about inter-arrival time. Simulation is not going to use that information at all. And the same for PCB2, the same arrival information. Okay, so we get one batch of 500 PCBs all together, perfect. With quantity each and occurrence, you can take care of that. For the processes, it's easy. If I were you, I would just pick PCB1 entity and would just use the click method, go from PCB store to area 1 and then area 2 and then area 3 and then leave the system. For PCB2, go from PCB store to area 2 and then 1 and then 3 and then leave the system. And we put the processing times for each one of them. I gave you the processing times and make sure the keyword wait is there. Okay, make sure the keyword wait is there. Otherwise you would get error. Simple processes. So everyone should have been able to put together the processes. And I would always recommend for these scenarios, take care of one PCB first and then go to the next one. Take care of PCB1, put everything for PCB1 and then go to PCB2. Let's go through the routings together. So for PCB1, we go from PCB store to area 1 and then from area 1 to area 2 and then from area 2 to area 3 and then from area 3 to exit. Okay. That's what I also mentioned here, going from PCB store to area 1 and then area 2 and then area 3 and then exit. And I gave you the processing time for each one of these areas. For PCB2, we go from PCB store to area 2 and then area 2 to area 1 and then area 1 to area 3 and then area 3 to exit. And I gave you processing times in each one of these areas, and each one of them, and all of them have exponential distributions. So make sure to put that as, okay? We want to run the simulation. Do I need to specify simulation runtime?
No, because it's only one batch.
Exactly. When I, like other simulation models, I do not need to specify any runtime in the simulation options window, simply because we have already told the simulation that I only get one batch of 500 and that's it. So when we get one batch of 500 and process them, then there's nothing to do in the simulation. So simulation will stop automatically. Okay. So when your number of occurrences are limited and simulation is done processing those entities, then simulation stops automatically. I don't need to specify any simulation time in the simulation option window. All we need to do is to just run the simulation. Make sure to turn off the animation. So if I ask you, how long does it take to process one batch of 500 PCBs of each type, what would be your answer?
3 hours, 45 minutes.
3 hours and 43 minutes. So that would be the time that would take for the simulation to process these entities and send them out. That's the time that it takes to process 2 batches of 500 PCBs of each type in this manufacturing facility. 3 hours and 43 minutes. Okay, so if I ask you a question like that, that's where you can get the answer. Both PCB1 and PCB2 exit is 500. PCB1 took about 47 minutes to process. PCB2 took about 22 minutes to process.